Messenger Robot 1 is a 4-wheel omnidirectional robot with various subsystems. The chassis has been designed on the basis of stress and strain analysis. Designing and analysis of Messenger Robot 1 is done using SolidWorks software. The Messenger Robot 1 is fully autonomous. We have used two approaches, odometry and line following. We have used odometry for the forest, line following for the bridge, and again odometry for the rest of Kangai area. The first step is to align the robot using the jig. By doing this, we define this position as 0, 0 and the direction of x and y axis according to this orientation. Now, when the robot moves in the arena, it needs to know its current position with respect to 0, 0. For that, we are using two rotary encoders of 1000 pulse per revolution coupled with 58 mm diameter omni wheels. Both the encoders are mounted perpendicular to each other at the bottom of the chassis. The design is such that both the wheels always remain in contact with the ground. For the robot to know its current orientation or yaw, we are using IMU sensor. Two main algorithms, omega control and dynamic axis, work continuously to carry out odometry. Once we define the x and y axis of the robot using the jig, any change in orientation of the robot won't affect the x and y axis using dynamic axis algorithm. Omega control algorithm maintains the desired orientation of the robot. It takes the input of yaw from IMU sensors, feeds it into a control system generating the direction and magnitude of the omega. Here, the robot is instructed to move from 0, 0 to x, y with some velocity. In case of deviation from the path, we have developed an algorithm which brings the robot back on its path. These algorithms cumulatively work together to make the robot reach its final position. Here's the top view of Messenger Robot 1 tracing sine wave using odometry in the forest area. After forest, we have used line following at the bridge for better accuracy. To carry out line following, we have used two LSA08 sensors. For keeping the robot on the line, we have used two algorithms, line control and omega control. Line control algorithm takes the feedback of the forward sensor and generates direction of velocity. Omega control algorithm takes the feedback of both the line sensors and generates the direction and magnitude of omega. At the end of the bridge, a servo motor is used to change the direction of geargay's face according to the direction of motion. The Kangai area after the bridge is crossed using odometry. Our Messenger Robot 1 is compatible to perform in any site of arena.